Bonjour à tous. Bienvenue. N'applaudissez pas tout de suite. Bienvenue pour cette première conférence du DevFest. J'espère que vous êtes tous en forme. Je vais vous demander un premier effort dès le premier talk, c'est-à-dire que je vais switcher en anglais. Because our first talk will be in English. It will be about WebAssembly. I think you know WebAssembly inside the browser, but Mete here will introduce us how WebAssembly could be used outside the browser. So please welcome Mete Atamel from Google in London for the talk.
Thanks very much. Thank you. Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google, based in London. And I've been meaning to come to DevFest Nantes for a long time, but there was pandemic, there was this and that, and finally I'm here. I'm very happy to be here in this great conference. Thanks for the organizers for this awesome, well-organized conference. So today I want to talk to you about WebAssembly, but especially when it comes to running it outside the browser. What it means to run WebAssembly outside the browser, what can you do with it, what's the state of it. That's the point of my talk. If you want the slides, I have my speaker deck, so you see the link here. You can get the slides from there. I'm going to share the slides at the end of the presentation as well, and the demos I'm going to show, they're already on GitHub, and I'm going to share that as well. So everything I talk about and show you today, they will be available to you at the end of the presentation. Before I start, at Google Cloud, I work for Google Cloud, so we have this Innovators program, where you can get credits to run stuff on Google Cloud, and you can also get like personalized learning paths and things like that. So if you're interested, there's a QR code to sign up. Feel free to check it out if you want. All right, first, let's talk about what is WebAssembly and why we should even care about that, okay? First of all, if you go to WebAssembly website and check the definition of WebAssembly, it says WebAssembly, also known as Wasm, is a binary instruction format for a stack-based virtual machine. So it's a virtual machine, and it's designed as a portable compilation target for programming languages. So you compile your application to Wasm module, and you run it in a virtual machine. So if you are coming from a Java background, it sounds a little bit similar, you know, just kind of like JVM and Java, how you compile it and run it. So it's similar in that sense. But at the same time, it's different because it's not just for the Java ecosystem. It tries to be more than Java, and we'll look at what that means later. And the original use case for WebAssembly was to augment JavaScript in the browser. So for better and or worse, we are stuck with JavaScript in the browser, and the things that you can do with JavaScript is limited, right? For example, if you want to run some game, usually that's written in C# on Unity, and taking that code and converting it into JavaScript is not viable. So the idea here is that you can compile it to WebAssembly and run it in a fast, portable, and secure way within the browser. And all major all major browsers, they support WebAssembly, and they've been supporting it for a while. And this is exactly why I kind of ignored WebAssembly for a long time, because I'm a backend developer. I build cloud services. So WebAssembly didn't look like it was something relevant for me. It looked like it was something for front-end, and it's not even regular front-end. It's for high-performance 3D graphics kind of front-end. So that's why it wasn't really interesting to me for a while. But then I started seeing some tweets. First, there was a tweet from Lynn Clark that introduced WASI, which we'll talk about, WebAssembly System Interface. And she was talking about running WebAssembly outside the browser with WASI. And more interestingly, Solomon Hykes, who's, I think, the founder of Docker, made the statement that if Wasm and WASI existed back in 2008, maybe we wouldn't have needed to create Docker. Now, Docker and containers have been the de facto standard for packaging and running applications, especially in the cloud. So if this WebAssembly stuff is something that's comparable to that and maybe can replace containers, then maybe it's something that I need to pay attention as a backend and cloud developer. So that's when I started looking into WebAssembly, and especially when it comes to running it on the server side. And there was a survey from CNCF last year, And one of the key findings for that was that containers are the new normal, and WebAssembly is the future. Again, this kind of enforces the idea that maybe WebAssembly is kind of the next thing, the next evolution of containers. So what does it mean, WebAssembly outside the browser? Well, there's an attempt to get WebAssembly to run outside the browser using the WASI project that we'll talk about. And the idea here is that instead of running our applications on virtual machines, or instead of running them in containers, we can run them in a faster, smaller, more secure, more portable way using Wasm modules. That's the premise, right? So if that's the case, why not, if we can do all of these in a faster, more secure way? But what does it mean, like faster? Well, Wasm applications, the Wasm modules, they tend to start with no cold start. So for example, with containers, there's always some time that you need to wait for the container to start. And it all depends on the container size and what you have in the container. But it's usually 300 to 500 millisecond latency. Similarly, if you are using serverless functions on Google Cloud or AWS, there's always some latency when it starts up. Whereas Wasm modules, they have minimal latency when the module starts running. So that's the faster part. The second thing is smaller. So a Wasm compiled Rust container, well, first of all, the Wasm module itself, like if you take your code and compile to a Wasm module, that's small. But even if you take that Wasm module and put it in a container, that can still be 3 to 20 times smaller than a native Rust container. And there's a blog post from this person that you can go and check out that gives you all the details of why this is the case. And I'm going to show this later when I talk about containers and Wasm modules. But they tend to be the Wasm modules, even within a container, they tend to be much smaller. More secure. So containers, they tend to have this allow by default policy, meaning everything is allowed by default, and you need to go to your container and kind of harden it and solidify it and make it more secure. And it makes me really nervous because I know how to build containers, but I'm not a security expert, so it always makes me question, like, did I harden things enough, to make it secure? Whereas in Wasm, everything is denied by default. So the sandbox they have is basically literally nothing is allowed. So if you want to allow something, let's say there's a function in your Wasm module that you want to expose to the outside world, you need to export it. Or if your Wasm module has to access the file system, the runtime has to enable that, right? So because of this policy, it's more secure because you can't mess it up. Like by default, it's not going to work. So you need to figure out what you need to enable. And finally, it's more portable. Sometimes we forget that we need to build our code for certain architectures. So the container, for example, built for Linux AMD 64, it's not going to work on Linux ARM 64. Whereas in Wasm, you build a Wasm module once, and then you can run that anywhere where you have a Wasm runtime. So it makes it much more portable than containers. So this all sounds good, and this kind of makes me think, maybe Wasm is the next evolution in this, evolution of hardware, VMs, containers that we had. And today we are at this stage where we have containers running, and we don't really think about the underlying infrastructure so much anymore, because we have things like Cloud Run, for example, on Google Cloud, where you just run the container. But maybe the next evolution will be a Wasm module that's smaller, faster, more secure, and you just run that instead of having to think about containers. I mean, this is a question. I don't know if this will be the case, but it feels like we are going in that direction. Okay, so this is all good, but you might be wondering at this point, what kind of things I can use Wasm for? What are the main use cases? And there's this really good blog post from Fermion, which is a startup focused on WebAssembly. And they outline 4 main use cases for Wasm, and I kind of agree with them, so that's why I want to explain that a little bit. The main use case for Wasm that's been around for a while is the browser use case, where you have your native code running in the browser. That's been around for a while. It's supported by all major browsers, so that's a very well-established use case for Wasm. So if you want to run high-performance graphics in the browser, think about Wasm. Now, the second area that's coming up is the plugins and edge case. These are the cases where you have something running in the edge, and you want your customers to plug in their code for whatever reason. And for that, Wasm is a good choice, because first of all, your customers can use any language they want and compile to a Wasm module. And secondly, the security model of Wasm is good in that case as well, because you have this sandbox. So if the code is not great, because you cannot trust it, it's enclosed in the sandbox. For example, Shopify has something called Shopify Functions. And there you can deploy your Wasm module for the checkout experience. And for that, they use Wasm because it's customer code that they don't trust, but it's a way for them to give customers a way to customize the checkout experience. Another use case is from Envoy. Envoy has its filters, and they allow you to plug in your filtering code in their filter chain. And for that, they also allow you to do Wasm modules, again, for the same reasons. You can use any language that WASI supports, but also you have the sandbox to protect if something goes wrong. So that's the second area that's coming up. The third area is IoT, and that's obviously because WebAssembly is very small. The WebAssembly runtime, some of them are really small, so it makes it suitable for IoT devices. And I've seen some runtimes focused on IoT devices. And finally, the last area that's coming up is the cloud microservices. And the idea here is that we already have this code running in the cloud, whether it's running in containers or whether it's running in just functions, it's there. Can we take that code and compile it into Wasm module and run it in a faster way, more secure way? So that's the premise there. And Fermion, the startup that I mentioned, they have a framework called Spin that tries to help with that. And cloud microservices is the part that I'm also most interested in, because that's what I do. And that's the area that I will look into in more detail for the rest of the presentation. OK, so hopefully this gives you a quick idea of what WebAssembly is, and especially when it comes to running it outside the browser. Now let's look into some details, Wasm runtimes and the WASI spec. Now, as I mentioned, normally you take your code, compile it for an architecture, and create a container for that architecture and run it there. Whereas in Wasm, you take your code, compile to Wasm module, and that's it. So you don't need to think about architectures. This might not seem like a big deal, but it actually frees you a lot. You don't need to think about containers. You don't need to think about what I need to put into this container to make this work. All you need to worry about is, here's my code, compile to Wasm module, and that's it. And then as long as you have a runtime, it will just work. Now, once you have the module, as I mentioned, you can run it on multiple different environments. All you need is the runtime. And these runtimes, there's a lot of them. So there's Wasm Time from Bytecode Alliance project, which is the body that's behind the WASI spec. There's Wasm Edge from Cloud Native Foundation. There's Wasmer from a startup. So these are the main three that I see most people use. But there's actually a list of them. And let me show you this. There's a GitHub page where you can go and check out all the different runtimes, that you have, and their specialties, let's say. So if you want to use one, check it out here, because this page has a lot of information on what's out there. But there's a lot of them, as you can see already. OK, so once you have your module running in the runtime, now to run it outside the browser, you need a way to interface with the host. For example, maybe you need a way to write something to the host. And the way you write to the host is different depending on the host, right? So the way you write a file in Linux is different than the way you write a file in Windows. So for that, we have WASI, WebAssembly System Interface. And this interface tries to abstract away the common host things so that the Wasm modules can talk to the host in a common way. Now, WebAssembly, it's POSIX-inspired, so it tries to implement the small subset of POSIX functionality. such as reading and writing files, reading program arguments, reading environment variables. But a lot of WASI is still in proposals. There's actually a link you can click and go, and it will show you all the different proposals and their state. Some of them are implemented, some of them are not implemented. And one of the main things that's missing, for example, is socket support. So there's a proposal for sockets, but it's not implemented yet in all the runtimes. It's not finalized. So what that means is that if you want to write, let's say, the microservice in WebAssembly, you can't read and write from a socket, and that's quite limiting, right? Because of these limitations of WASI, some runtimes, they started implementing some workarounds. For example, the Wasm Edge runtime, it has extensions for sockets, so you can use sockets with Wasm Edge. But these extensions, they only work for Rust, JavaScript, and C. So it's, again, a very, very small subset of languages. Similarly, there are some projects that they try to enhance WASI. For example, there's a project called WAGI, which I'll talk about next. And WAGI tries to add HTTP handling around your Wasm modules. That way, your Wasm module doesn't have to understand HTTP or sockets. It can just do its work. And the WAGI does the HTTP handling in and out of your module. And I'll show you an example of this later. There's another project called WASIX that tries to add full POSIX support to WASI. But it's not a standard yet, and it's only supported on Wasm runtime, and it only works with Rust on a certain version of Linux. So as you see, there's a lot of caveats with that as well. And there's no garbage collection in Wasm right now, but there's a proposal. And because of this garbage collection, you can't easily support languages like Java or Kotlin or something like that, because you need garbage collection. But there's a proposal to implement that, so hopefully it will happen, and we'll be able to have these languages running easier on Wasm. So you see, WASI is a good step in getting WebAssembly outside the browser, but it's still very early on, and a lot of things are still missing and changing all the time. OK, now let me show you a quick demo. So let's say you have a piece of code, and you want to compile that code to a Wasm module and run it with a Wasm runtime. So let's see what that looks like. I have a repo with some samples. So I show you how to do this with Rust, with .NET 8, with Go, with Kotlin. And as I work on more languages, I'm going to keep adding to the repo. So feel free to check it out. But for now, I'm going to show you Rust, because Rust is one of the main supported languages in Wasm. So let's see what that looks like. First, let me go to my IDE. OK, so I have a README, so I'll just go through that README with you quickly. First, you need to have Rust and Wasm runtime installed on your machine. So if you see, I actually have Wasm time installed. And then if I do Wasm Edge, I have that installed as well. You can use whatever runtime you like. To get Rust compiled to Wasm, you need to add this Wasm WASI target. And the way you do that in Rust is that you just say Rust up target add, and add that Wasm support. So I already have this, but you'll see that if you don't have it, it will just download and install it in your Rust toolchain. So I have that already. Then you create a new application, and then in the main file, you do whatever you need to do. I'll just show you that file quickly. I'm just, in this main file, I'm just doing a hello world, so it's a hello Wasm. But I'm also writing something to my host to show you that my module can talk to my host, basically. So here, I'm creating a file /hello world /helloworld.txt. So I'm creating a file in that folder. And then I'm writing some hello world to it, and then I do another println. So it's something very simple. But the key point is that we are writing something to the host from the module. So once we have that, to build the Wasm module, you will just do cargo build, and then you just pass the target. And in this case, the target is Wasm WASI. Let me see first of all, let me see if I have I already have. So let me do cargo clean. So I will clean, and then right now, I don't have a Wasm module. And then let's just do cargo build. So this will take the code and build the Wasm module. And then if I do that, you see that under debug, I have this module. And then to run it, you basically just use a runtime and then point to the Wasm module. But again, this module tries to access the file system, so we need to enable that. Keep in mind that in Wasm, everything is denied by default. So in Wasm time, you do that by map directory. So I'm just saying here, the /hello world in my Wasm module maps to this current directory on my host, okay? And then I just point to my module. So let's do that, and let me remove the hello world. So I don't have the hello world. I run it, and then you see it says hello Wasm, and it created this hello world, wrote some things. So nothing exciting, but it proves the point that this works. And then if you take the same thing and run it on a different runtime, it will work the same way. You can even take the same module and run it on a Linux or Windows or whatever. It will still work. That's the portability of Wasm. So that's how we can run, compile and run a Wasm module quickly. And how you do this in .NET is different. How you do this in Go is different. Every language, they have their own tool chain, and every language have their own maturity level. So you need to check the language you're interested in to see what it supports. And I'm going to talk about more about languages towards the end of my presentation. All right. So now we got the Wasm module, and the next step is that I want to look into is running WASI in Docker, because I've seen that Docker has some support for that. But at this point, you might be wondering, why run Wasm inside a container, right? Because Wasm is supposed to be smaller, faster, everything than a container. So why take that and try to put it in a container? And that's a good question. And the answer is that, we are in this state where we don't have a Wasm ecosystem yet. We don't have a way to store Wasm modules. We don't have a way to push them, pull them. So even if you can build your Wasm modules, how are you going to use them, right? How are you going to store these modules? How are you going to get them? What's the tool chain? It's not there yet. So I think by combining Docker and Wasm, we are kind of combining the current world with the future world. So you can still use Docker and Docker push and Docker pull, all that kind of stuff. But you are doing that in a more efficient way using Wasm modules. So that's the idea. Not because it technically makes sense. I think technically in the future, it will be just Wasm modules everywhere. But in the meantime, we are kind of wrapping them on a thin layer in a container so that we can kind of marry the future with the current state of the things. All right. And this is enabled by a project called Run WASI. It's a project to enable containerd to run Wasm modules. So in Docker, starting with 4.15, there's some support for Run WASI, and Docker supports these 4 runtimes: Wasm Edge, Wasm Time, Spin, and Slide. So it doesn't support all runtimes, just these 4 for now. Azure also has an AKS preview for Wasm module node pools. So supposedly you can create a Kubernetes cluster with Wasm node pools. I haven't tried it to see if it works, but I tried the Docker one, and I'm going to show you that next. And there's this really good blog post from Nigel that shows how this works in containers. So normally, you have Kubernetes, and underneath you have containerd managing runc, and the runc is the one kind of creating and running containers. So that's the world that we have today. But in this new world, we have containerd managing not only runc, but also managing Wasm runtimes through a special shim. And then if you look at this shim under the covers, this containerd uses one WASI project, and it uses the Wasm runtime to basically create and run these Wasm modules. So as you see, because of that, like now you have these 2 worlds kind of working together in the same kind of space. So if you want details, feel free to check out this blog post. But now I want to show you, okay, we built our application. Now, how do I run that in a Docker container? So let's take a look at that. So for this one, I'm going to use another Rust application. And this one is pretty much the same with slight difference, so we can see that it's a container. So let me first close the Rust. OK. So in this one, first, you need to make sure that you have Docker desktop latest enabled, because that's where well, I think you can have Docker 4.15, but it's good to have the latest one because they have some changes. And you also need to make sure that the Wasm stuff is enabled. So if you go to settings in Docker, and if you look under features in development, there is first use container D checkbox, so you want to make sure that's checked. And then under here, there's enable Wasm checkbox, so you need to make sure that that's enabled as well. So that enables the Wasm runtimes in Docker. So once you have that, you can start using Wasm in Docker. We build our application, and the only difference here with the application is that I'm not writing anything to the file system. I'm just saying hello Wasm, wait 10 seconds, and then hello Wasm afterwards, so that I can see that a container is running. I'll show you that. So I have that, and I built my Wasm module just like before. So let me make sure I have that module here. Yes, I already have that built. And then we already configured our Docker. And the last thing we need to do is the Docker file. So if you look at the Docker file, so I'm now putting this container into this module into a container in a way, but I'm based on the Scratch image. Scratch image is basically an empty image in Docker. And we can do that because Wasm module is self-contained. And also there's Wasm runtime that's supplied by Docker. Because of that, I don't need to worry about building my Docker container, like what I need, dependencies, anything like that, because my module has everything I need. So I'm based on the Scratch image. I just copy my module to here, and then I just run it. That's it. And then to build the image, it's just like a regular build. So let's actually do that. Let's call this 03. And this should, yeah, my Docker's, whenever I'm connected to Wi-Fi, it stops working. I need to restart it, and it takes a while. But basically, you can trust me that it builds. And then if you do Docker images, even that doesn't work. OK, well, the container is there. But maybe I can. Yeah, it's running. But yeah, there you go. So the container is there, and then you can run it. So to run it, you need to tell Docker which runtime you want to run it with, because Docker has 4 runtimes for Wasm. So in this case, we are using Wasm Edge. And if we do this, then this should run just like a Wasm module, but with Docker. So it's, in a way, it's in a container. And then if we do Docker PS, we should see that there's a container ID and so on and so forth. But it's a very thin container. It's not really a container. It's more like a Wasm module run by Docker, in a way. So yeah, that's it. And then once this is done, you can push this image to Docker Hub. Well, my Docker is not working, but then, and then if you look into, let me see where I have that. If you look at Docker Hub, I already pushed it. So you see the Wasm is there, just like any other container. That's why kind of combining Wasm and Docker kind of makes sense, because we can work with it. We can push it, pull it, run it, and things like that. So that's basically it in a nutshell. And now I want to point out to this blog post that I was talking about. So in this blog post, this person, they try to compare what it takes to run Wasm natively in Docker, Rust natively in Docker, and Rust on Wasm in Docker. And he did a comparison. And the interesting thing is that, he did a hello world. He compiled to Wasm module. Then he basically built his image, just like I showed you. And then he did the same thing by just building a Rust application, a self-contained Rust application. So here, you can pass the Rust flag, and that builds a self-contained Rust application. And then he wrapped that into a container too. So you have 2 containers, one native Rust, one Rust compiled to Wasm wrapped into a container. And then he compared the results, and it's like 3 times difference. So the Wasm one is 3 times smaller than the native one. Of course, this is because, in Rust, you need some base image, right? And that's why and then this self-contained adds like extra things to make it work. So that's why it's more. Whereas in Wasm, the runtime is supplied by Docker, so you're not putting that into your container. So that's kind of the difference. But he went ahead and started building more complex images. And in this last one, he was trying to add HTTP support and all that kind of stuff. And basically, the end of the story is that the native one ended up being 120 megabytes because he had to add like SSL support, for Rust to work with HTTP, whereas the Wasm one was 1.2. The 1.2 one was 5.3 megabytes. So there's a big difference here. Of course, this all depends on what you're putting in your container and how you're optimizing it, all that kind of stuff. So maybe it's not apple-to-apple comparison. But you can see that, in general, the Wasm module itself is small. But even when you wrap it into a container, it still tends to be smaller than if you had to build the container yourself with the native application. So that's like the big conclusion from this blog post. And you can get the details if you're interested. All right, now, next thing. So we have it running in container, but it's not that useful because I can't do HTTP yet. I can't build a service out of it, right? So I can do some CPU stuff, but without HTTP, I'm limited on what I can do. But thankfully, there's some projects coming up that's helping with that. One of them is called WAGI, which is WebAssembly Gateway Interface. And if you remember, there used to be something called CGIs. So it's similar idea with CGI, but for WebAssembly. And the idea here is that, you have your modules here, module 1, module 2. They don't know HTTP because they are running on WASI. But then you have WAGI, where you define your module paths. And then you can say, when path 1 comes in, WAGI reads that HTTP. It checks which module it should go to, and it will direct that to module 1. And module 1 will read that HTTP using console. So it will read it from as program arguments and things like that. I'm going to show you an example. And once it's done, it will write it to standard output. And that will get translated into HTTP. Okay? So we are kind of cheating a little bit. We are reading from console. We are writing to console. As if, and then taking that and converting it into HTTP using WAGI, okay? And similarly, when path 2 comes along, it will match it to this other module, and so on and so forth. So the way this works is that, for example, I'll show you a quick example. Where is my WAGI? So here, I built 2 applications. One of them is a .NET 8 module. And if you look at this .NET application, I don't know if there are any .NET developers here, but you can still understand the code. So in this .NET application, what we are doing is first, we are writing, so we receive a request, and then we need to reply back. And to reply back, you're writing you basically write a console application. So we are saying, my content type is text plain, and my HTTP status is 200. Okay, that's my reply. Then you leave an empty line, and then the rest is your body. So here I'm just saying hello WAGI from C#, okay? The headers of your HTTP, they are placed in as environment variables. So that's how you can read the HTTP headers. And the query parameters of the HTTP, they are sent as command line options. Well, at least that's the idea. In C#, this doesn't work. I couldn't get it working, but it's supposed to work that way. So you see how you can read HTTP headers and HTTP query parameters that way, and you can reply back with just writing to the console. Now, so I created this and created a Wasm module out of it. Then for the second application, I created a Go application. And in Go, it's similar things, right? So again, when I receive so this is a console application. I receive a request. I do HTTP 200 from here, and I write my body as well. And to read the headers, again, I am reading the environment variables. That's how you do it in Go. And to read the HTTP query parameters, I'm just reading it as command line options, right? And that's what I will do. So once you have these modules, all you need to do is you need to define this modules file. And here I'm saying, OK, if I have a /C# path, send it to my C# compiled Wasm module. If I do a /go, then send it to my Go compiled Wasm module. Okay, so that's how you can direct it. And then to run this, let me see. I already have WAGI installed on my machine. I won't show you how I create these applications. You can check them out later if you like. But what I want to show you is how to actually run this. So we do WAGI-C modules. So let's do that. Now WASI is starting, and it's starting on 3000. And now if I do a curl to C#, so let's do it from here. You see that C# responded with hello WASI from C#, and it's also telling me that it read these environment variables. And then if we do curl and add some query parameters to it, because in Go this works, you can see that the Go responded as well, and it wrote the HTTP headers as environment variables, but it also figured out the query parameter of arg and value. So it's a little bit hacky, you know, like it doesn't feel natural for HTTP, but it's at least one way of running HTTP with WASI when WASI doesn't have support for it yet. All right. Now the next thing that's coming up is called something called WASIX. So the idea of WASIX is basically, let's extend WASI and add all the missing POSIX features, because we need networking, we need multi-threading, we need all these things, right? So why don't we add them in? I think it's coming from the frustration that some people feel because WASI is kind of evolving so slowly. It's been a while, a few years, and they are kind of, I feel like they're kind of using WASIX as a way to push the WASI world in a direction where we have these features. I try to use WASIX, but it's very limited on certain languages like Rust and C, and it's very limited on certain versions of Rust, and it's very limited on certain versions of Linux. So it's not like widely available yet, and it's not a standard either. But it's something to keep an eye on, because I think eventually we'll have WASI evolve into something like WASIX. But it's not there yet, so it's something to keep in mind. All right, I showed you this demo already with WASI, so I don't need to do that. OK. So the last thing that I want to talk about is the frameworks and languages. So there's a lot of Wasm frameworks out there for different reasons. But if you are interested in kind of microservices, Wasm kind of microservices, I suggest you look into Spin. It's an open source framework by Fermion, a company that's in this space. And it seems to be the most up-to-date and most comprehensive kind of framework to run microservices in different languages on WebAssembly. And they have an SDK in Rust, Go, and .NET, and a bunch of other languages. So I highly recommend you to check that out. And I have a demo. Maybe I'll show you this quickly as well. Let's go to here. So if you have Spin installed already, all you need to do is Spin has a bunch of templates that it comes with. So let's actually look at some of them. So let's say Spin. If you do Spin Niv, you see that there's templates for C, Go, Grain, JS, PHP, Rust, so on and so forth. And then you can do Python. You can give your application, let's say, hello, Wasm, nonce. And that's the path that you want to hit. And then it basically creates this application for you. And then if you look at the application.python, it's kind of like a serverless kind of application, right? Like you have an HTTP request that's coming in, and you just respond with 200. So that's the kind of thing that we are used to, right? This is possible because under the covers, Spin uses WASI. So it uses WASI to do the HTTP handling, and then it responds back. But you don't need to know all those details. It just gives you this, and it just works. And to run this, first, you would build. So you would be like Spin build. And it handles how to take your code and create a Wasm module and all the details for that language. And actually, if you do a find, we see that there's an app.wasm created. And then to run it, you will just be spin up, and then it will figure out how to, well, unable to listen. Maybe address already used. So I'm already running. OK, this is the WASI that's running. So let's kill that. So they're listening on the same port because it's using WASI under the covers. And if you go there, you will see that it says hello from Python SDK. And this works pretty much the same in most of the languages that they support. So they hide all the details of WAGI and Wasm and how to build all that and everything, and they give you a simple interface like spin build, spin up to get your applications up and running. All right, so that's that. And the very last thing I want to mention is language support for Wasm and WASI. One question I get is that, you know, I'm on language X, and what can I do with that language on Wasm? And that's a good question, but it's so hard to answer. The reason is that, number one, you have WASI limitations for that language, so you can't take the language and do everything of that language in WebAssembly. You have limitations from WASI. And secondly, different languages have different levels of support currently. So even if you can do things, maybe the language doesn't support it yet. The language toolchain doesn't support it yet, okay? And there's also a lot of misinformation out there. For example, if you look at this link that lists different languages and their Wasm and WASI support, here it says, you know, Java has good WASI support, which makes you think that, oh, okay, like I can run my stuff in Java on WASI. But that's actually not the case, and I'll explain you shortly what I mean. Or here, for example, Rust is one of the languages that's it's supposed to be supported quite well on WebAssembly, and it is. But you need to keep WASI limitations in mind. For example, in Rust, you can't have async, or you can't have multiple threads yet because of WASI limitation. So what that means is that you can't easily run Tokyo or async with Rust. So that's quite limiting. With C and C++, again, they have excellent support for building Wasm modules, but you can't use C++ exceptions. Well, without exceptions or threads, it can be quite limiting. Go has support with TinyGo. It's a separate project, but you can't do reflection. And then the latest Go, 1.21 RC, they started having support for Wasm modules as well, so you don't need TinyGo anymore, so I need to check that out. In C#, for example, there was some support for WASI via WASI SDK in .NET 7, but in .NET 8, they changed that completely, and they made a WASI experimental workload that you can install and run, which I tried and it works, but it's totally different, and maybe by the time .NET 8 is released, it will be even more different, I don't know. Java, the excellent support that's claimed in this link, it comes from something called TVM, which is a Java to JavaScript compiler, but it doesn't work in TVM. You need to use a fork from Fermion, the startup, that added WASI support on TVM. So if you use the fork from Fermion, you might get it working. I tried, I couldn't get it working. Maybe I didn't do something right, but yeah, so the excellent support is not so excellent in my opinion. And finally, the Kotlin, they are supported. I have an example of this in my repo, but it's only supported via Node experimental WASI API, which I think means that you need to have Node.js installed locally so that you can compile Kotlin code to a Wasm module. So that's also kind of limiting. So you see, the language support is it's very patchy and it's very limited. And we'll see how it evolves. And I think this is one of the things that's kind of blocking the adoption of WebAssembly on the server side, because it's so hard to understand like what's available today and what you can do with it, basically. That's the summary. All right, so I will finish my talk with some conclusions. Now, WebAssembly outside the browser, it's a fast-changing landscape. Every time I look into it, something changes. Some language adds some support, or the way you do things in certain version of a language changes in the next version of the language. So you need to really pay attention and keep up to date with it, because it's changing and it will be changing until WASI is finalized and all the languages support it in a major way. The standards and language support, they need to mature. So WASI needs to move faster, I think. And projects like WASIX, they need to figure out how they're going to be standards. Or if not, I don't think people will adopt them. So we'll see how the standards evolve and what happens in the end. Will it replace containers? I think it has the potential, because if you can take the same code and make it a smaller Wasm module and run it in a more secure way, then yes, everyone wants that. But the whole ecosystem also has to change, and we need to have tools around it. We need to have language support around it. So I think we are still far from that, but we are moving in that direction. So it's definitely a good time to learn this technology, keep an eye on it, and make sure we know what's happening. And maybe at some point it will be the default way of running code in the cloud. We'll see. I don't have a strong opinion either way, but I think it has the potential. All right, so that's all I had to say. So if you want to get the slides, this is my link. If you want my demos, this is my repo, and I have many more things in my repo than what I show you. And yeah, I think the conference has a feedback link, so don't use my feedback link. Please give me feedback, because I always appreciate your feedback. So yeah, thanks very much for listening, and enjoy the rest of the conference.